To solve this equation, we can look at this and we can see that we have to isolate x, and we have an x here and an x here. To be able to solve for that x, we need to be able to group those x's together. Now in this case, because they are not like terms, they cannot be grouped together, so we're stuck. So we have to look at this and say, well, can I factor this? First of all, is it equal to 0? Okay, because if it's equal to 0, then we can solve by factoring. Here we have a common factor of 2e to the x, so it can be factored. If it can be factored, we can solve the factor parts individually, independently of each other if the factors are equal to 0. So I'm going to factor this. So I have 2e to the x, and then the other factor is going to be e to the x, so there's going to be 1 e to the x left when I divide that out, minus 3, and that's going to be equal to 0. And again, it's important that it's equal to 0 because now we can use the 0 property of multiplication. We can say that each factor can be equal to 0, and that would make the whole equation 0. So here I can say that e to the x can be equal to 0, and this would solve the equation. In this case here, though, e to the x is never equal to 0, so there's no solution. Okay, so this is an exponential function. If you were to imagine what this exponential function looks like, it's a graph that looks like this, and it never crosses the x-axis, so there's no solution. So then I move on. I can look at this factor independent from the e to the x, and I can come up with an equation here. E to the x minus 3, that factor could be equal to 0 as well, and it would make the whole equation equal to 0. Well, this I can solve. So I'm going to isolate the e to the x, and I'm going to convert this into a log. Okay, I need to solve for the exponent, so I need to use a log. So I'm going to use log base e. The basis for the exponent is e, so I need to use a log base e. The log is equal to the exponent. In this case, it's x. I'm going to end up solving for x. And then the argument should be the answer to the exponential expression. So x is equal to log 3 is the solution to this equation. And the other factor doesn't generate a solution. Now, we can always check equations by graphing. It's always important that if you run into something new and you're not sure about it, you graph it to see if that your solution that you got is the correct solution. For b, it's a little bit more complicated. We have this expression here. I have x's embedded inside sign. I also have x's in the exponent. Okay, so it's even more complicated than the previous one. Well, I can't isolate the x in the sign and the x in the exponent at the same time. Okay, that's not possible. I need to undo the sign with an arc sign. I need to undo the exponent with a log. Those are not going to be able to be undone together. So I have to think of something, an alternative here. It is equal to 0, and it is factorable. So I'm going to factor and see if I can come up with something I can use to solve this. So the greatest common factor is going to be, we have a common factor of 3, we have a common factor of sine x, we have a common factor of e to the x, okay, put that in brackets. So those pieces are factorable. Okay, what's left over in the brackets then, we're going to end up with 2. We have 1 e to the x left here, and this is just going to be minus 1. And that's all equal to 0. Again, it's important that it's equal to 0 because now, since it's equal to 0, each factor can be solved independent of each other. So when I take a look at the sine x, I can say that sine x is equal to 0, and I can solve that. Okay, so sine x is equal to 0. when the vertical component of the circle is equal to 0 at 0, pi, and then it's going to just repeat itself. So I'm going to end up with x is equal to 0, pi, 2 pi, dot, 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 dot. This could be generalized as x equals n pi, where n is an integer. Then I can move on to the e to the x. Well, e to the x again, that's an exponential expression. E to the x is never equal to 0. It never crosses that x-axis, so there's no solution. Okay, and then lastly, I have this factor here, and I have 2 e to the x is equal to positive 1. I can solve that equation. E to the x is equal to 1/2. Use a log to undo this, so log 1/2 is equal to x, and there represents the other solution. So there's one solution in here from the e to the x, 2 e to the x minus 1, and then there is a repeating solution based on the sign portion of this equation. And we can see this solution when we graph this as well.